So far, we have been running all of our Gatling scripts by executing them in the IDE through the Gatling Runner class. That's fine for debugging, but when we come to run our performance test in production and test environments, we will want to trigger them from the command line. We will look at how to do that in this video. Let's make one more Gatling script in our simulations package. You should be very familiar with this process by now. Right-click on Simulations and create a new Scala class. Call it Runtime Parameters. Extend the class and add the imports. Let's add in our API call quickly. We will make this script really simple and just call the getAllGames endpoint. Def getAllVideoGames equals exec http getAllVideoGames dot get videogames dot check status dot is 200. Now add in the scenario. Let's make it simple at first with just a single user, but we will make it loop forever and instead put a max duration in the load profile. Val scn equals scenario videogamedb dot forever exec getAllVideoGames. Finally, let's add our load profile. Setup scn.inject, nothing for 5 seconds. And although we are only going to use one user, let's make that user ramp up. You will see why shortly. Ramp users 1/1 seconds. Finish with the protocol of HTTP conf, and finally give the profile a max duration of 20 seconds. We need to add in the import to recognize seconds. Import scala.concurrent.duration.durationInt. Now, instead of running this test from the Gatling Runner launcher, let's run it from the command line. To do that, open up a command prompt and navigate to your project folder. I am now in the folder of the project code. Now to run our Gatling script from the command line, I'm going to do this by calling a Gradle task that comes bundled as part of the plugin we installed at the start of this course. If you want to read more about this plugin and how it works, you can browse to this site. But I'm going to show you how it works here. So to execute the Gatling script from the command line, type Gradle W, or if you're on a Mac, type /Gradle and then Gatling run -simulations.runtime parameters. The part after the hyphen of Gatling run is the name of our script. In our case, it's in the simulations package and it's called runtime parameters. Press enter and the script should run. Gradle now compiles our script and after a few seconds will execute it for us. Congratulations! You just learned how to execute Gatling tests from the command line, a technique that you will find indispensable when you come to add performance testing to your larger testing projects and build pipeline. In the next video, we will look at how we can add runtime parameters to our scripts, which we can then change on the command line when we run our tests. In the last video, we saw how we can run our Gatling scripts from the command line. In this video, we are going to amend the same script to have runtime parameters, which will allow us to pass parameters through the command line at runtime. So what sort of things would be good as runtime parameters? Well, you might want to set the number of users that the script should run, or the length of the performance test, the duration, or the ramp-up speed. You could set anything you wanted, but those are some of the likely candidates. To make our script ready for runtime parameters, let's first add a helper method to our script that will either read the runtime parameter from the command line or fall back to a default parameter when no parameter is passed. At the top of the script, declare the method with private def getProperty. It takes two variables, the property name, which is a string, and the default value to fall back to, also a string. Now type option system.getEnv property name. This will look for the property name as an environment variable. Then type or else option system.getProperty property name. If Gatling can't find the environment variable, this will make Gatling look for a system property instead. Finally, type .getOrElse default value. If Gatling can't find either an environment variable or system property with the specified name, the method will instead return the default value specified. Now let's specify the three properties we will use. First, the user count. Def userCount :int equals get property users, 5 to int. This will look for a property of users, and if it can't find it, default to 5 users. Now ramp duration. Def ramp duration :int equals get property ramp duration, 10.2int. This will look for a ramp duration property, and if it can't find it, default to 10 seconds. Finally, a test duration. Def test duration :int equals get property duration, 60 to int. Let's also add in a bit of debug code that will print out the properties to the command line at the start of the test. Before, print line running test with $userCount users, print line ramping users over $ramp duration seconds, print line total test duration $test duration seconds. Finally, we just need to modify our load scenario to make use of these properties. Inside ramp users, add in the user count parameter. Then add the ramp duration parameter. Inside the max duration brackets, add the test duration. That's everything we need. Let's go back to the command line and run our test. So on the command line, inside our project folder, we can type Gradle W Gatling run and the name of our test -simulations.runtime parameters. And now you add each parameter by first doing -d and the parameter name. So -d users equals 3, -d ramp duration equals 5, -d duration equals 30. Press enter. Gradle will build our Gatling test and run it. We can see that the test is running with 3 users, and we expect it to stop after 30 seconds. And it does. What about if we don't supply any parameters? Thanks to the way we coded our script, Gatling will fall back to the defaults. Let's run the test again, this time without the parameters. Sure enough, the test still runs, and this time it uses the defaults of 5 users and 60 seconds duration. Having this flexibility of being able to design and configure load scenarios at runtime is very powerful and works great in continuous integration environments.